Okay, we're going to go through the answers to the multiple choice in the October 23 exam for the Edexcel International A-Level for Physics, Unit 4, Further Mechanics, Fields and Particles. Okay, I've already made some notes because I made an attempt before, but I needed to record over it as the sound quality wasn't up to standard. So bear with me while I just want to zoom in a bit so we can focus in on the question we're interested in. Let's zoom in a bit more. Okay, hopefully you can see the script quite well. Question 1 is about an isotope, a nucleus of an isotope. Osmium, it contains 76 protons and 190 neutrons. So you basically need to know about the nucleon numbers in a nucleus for this unit and also for unit 5, which follows, and usually you'll study this unit 5 after unit 4. We're doing it the unit 4 in January, and unit 5 will be taken in the May or June exam depending on the date. So there are two numbers in a nucleus that you need to be aware of. The one number, the smaller number, is the charge number, which for a nucleus is the total number of protons, and the bigger number is the mass number, which is the nucleon number, which is protons and neutrons added together. So that's the only thing you need to do, is basically add the two numbers, work out the second one, and you will be able to get the answer straight away. Okay, so basically, apologies for that pop-up. The bottom number must be 76, so it has to be A or B, and the top number must be not 190, because that's just the neutrons. So when you add the 190 to the 76, you get a total of 266, so the answer is A. Okay, question 2 is about a decelerating vehicle. Car travels along a straight horizontal road, a drag force of 150 newtons, acts for 15 seconds. So in other words, the air resistance is going to slow down the car. Now this is obviously from Unit 1, this question, but in Unit 4 you do further mechanics, so they will also test you on your knowledge of Unit 1 should they feel it necessary. Okay, because the difference is in further mechanics you need to do conservation of momentum still, but you will do it not just in one direction, but you may get different components of momentum horizontally and vertically or at right angles to each other. This one is a very simple question. You just need to know that force is the rate of change of momentum, so delta mv, change in momentum, divided by change in time. The force is given to us 150 newtons, the time is given to us as 15 seconds. So if you rearrange the equation to get the momentum change, you just multiply the two numbers by each other, and you will see that the answer you come up with is C. So I'm not going to spend too much time on this question. We will go through the next one. Question 3. The tubes of a LINAC or linear accelerator get progressively longer along the length of a LINAC. Now, if you've revised, you will know that's true. You need to know why that's true. Which of the following is the reason for this? Well, A and B are mentioning the frequency as being a factor. Well, in fact, the frequency for the potential difference is constant, and that's how a LINAC works. So when you actually got the particle going round and round, or in this case in a linear accelerator, all that gets longer is the tubes. The tubes get longer. The particles accelerate between the tubes, and because they're going faster, to be able to be synchronized with the frequency of the potential difference, so the frequency, I should have written, the frequency of the PD is constant. The frequency of the PD is constant, and for that to enable you to keep the synchronicity with the particles as they exit each tube, in between the tubes is when they accelerate, then the time spent will enable the frequency of the PD to synchronize itself and to give it a push between the tubes. So D is the correct answer for this. If that doesn't make sense to you, that's an area where you need to make sure you have revised thoroughly. Okay? These questions come up in every exam. Okay, the next one is basically knowing the equation for magnetic flux, which will be in your list of equations at the back of the exam paper. So you need to make sure you know it. You need to also make sure you're very familiar with the list of equations. So phi is magnetic flux, B is the magnetic field density, flux density, or the magnetic field strength. A is the area that is interacting with the flux. So it could be a coil, for example, of area A in a magnetic field with the strength in Teslas. When you multiply the Teslas by the meter squared, you get Webers. So the magnetic flux is the multiplication of the strength of the magnetic field by the area where you capture the field lines. Okay, so the answer is A. None of the other answers can give you that correct combination. Question 5 is about Rutherford scattering experiment. Rutherford scattering experiment occurred around 1910, and if you go through these answers, I've ticked which ones are a valid conclusion, but the examiner is asking for which one is not a valid conclusion from the Rutherford scattering. So A, the nucleus contains most of the mass of the atom. Yes, that was one of the conclusions from the Rutherford experiment. You just need to know that. B, it says the nucleus contains protons and neutrons. Well, in fact, they didn't yet know what the nucleus was made of. So B is the correct answer. And you can just make sure that you've gone through the other two questions too, to make sure that you're not confused in this subject. The nucleus was found to be charged. That was a conclusion, because otherwise you would not have had any rebounding of the alpha particles. That's the only way you're going to get any rebounding. And if you remember, the prediction from the plum pudding model was that the alpha particles would very likely hypothesized to go straight through, or if they were deviated, it will be by small angles. And D, the conclusion that the nucleus is very small compared to the atom, was in fact one of the main findings of the Rutherford scattering experiment. So I've ticked the ones, A, C and D, which were conclusions, and the reason B is not correct is because they didn't yet know what was inside the nucleus. So in fact the neutron was not discovered until 1932. So that was much later. Okay, so I hope that makes sense to you. Question 6 is about a particle detector and a particle physics. So the particle detector shows two tracks produced by particles X and Y. The particles were created by the decay of a kaon at O. You will realize that it doesn't really matter how they were created, because the answers allow you to work it out. Which of the following can be concluded from the tracks? So this one is not, the previous question had not a valid conclusion. In this question they want to know which ones can be concluded. A magnetic field acts into the page. Well, we don't know if the magnetic field goes into the page or not. They haven't told us, so we cannot determine it because we don't know anything about X and Y. All we know is they're traveling in opposite directions from their creation at the beginning at O. Okay, so it says X is then, B says X is a positively charged particle. Again, we do not know the charges because we don't know the direction of the magnetic field, and Y is an electron. Again, we can't tell whether it's an electron or not. The only thing we can tell is that X and Y, because they're moving in opposite directions in the same magnetic field, they must have opposite charges. So by process of elimination, we know that only D is possible. So it doesn't really matter what the particle is made of, the initial particle. Okay, we're over the page. We're going to questions 7 and 8. So I'm just going to zoom round. Okay, so questions 7 and 8 is also looking at two charged particles X and Y, and you need to understand that this is about circular motion, yeah, because a magnetic field is involved. And if you remember, mv squared over r is bqv, you can cancel one of the v's and come up with an equation which tells you something about the radius of curvature. Well, both of these, x and y, are following curved paths. Y has a much bigger curvature than x, and because we know that they're moving at the same speed in a uniform magnetic field is B is constant, yeah, same speed, V is constant. So we can basically eliminate V and B and they just give you a constant. So we're looking for the properties of Y, yeah, compared to X. Which row of the table describes the properties of Y compared with the properties of X? So this requires a little bit of thinking, and I would say question 7 is probably the most difficult question you've had so far in a multiple choice. All we can tell from the equation that we derived from circular motion is the radius of curvature is proportional to m and inversely proportional to charge. In other words, if m is small, r will be small. And inversely, if charge is large, then r will be small. Now for y, r is much smaller, yeah, the radius of curvature is much smaller than for x, where the radius is much larger. So r for x is much bigger than r for y. So we're looking for something that will give us a large mass to charge ratio. Okay? Now if the mass for y is greater, that will be a lower radius of curvature. It will be a larger radius of curvature, because if the mass is greater, it's proportional to the mass. So it looks like A and D are unlikely. For that to happen, then the charge would have to be substantially countering the effect of the mass. So A and D are going against our proportionality constant. But if you look at B, so A and D have missed out, B looks like the mass is small, yeah? So if the mass is small, the radius should be small. And then if you look across, if the charge is greater, again, the charge being greater, the radius will be smaller. So this has 2 ticks. This has 1 cross already. 1 cross already. We haven't checked, yeah, the other ones, but only one has 2 ticks. If the mass is the same, then we want the charge to be larger. So this one is definitely incorrect. So by a process of elimination, you don't have to go through every combination of the answers. Of course, it's more complicated than that, and it could be a scenario where the mass is greater, but the charge also compensates for that. But in this case, you go straight to B and you've worked it out. Don't spend too much time trying to go through and working out whether the other combinations could compensate for it. Okay, question 8 is about a toy aeroplane. A toy aeroplane in a circular path. So you've got circular motion again, so 2 questions on circular motion, which is a big part of further mechanics in Unit 4, and the reason why circular motion comes in is because the topic, Unit 4, finishes with particle physics, and the question before is why we use magnetic fields to analyze tracks of particles in a magnetic field. So here we're learning the mathematics of circular motion. It's 12 revolutions in 6 seconds, so it's 2 revolutions per second, but we wanted the angular velocity. The angular velocity is omega, yeah, and we want it in radians per second. Well, if it's doing 12 revolutions per second, 12 revs per second, yeah, 1 revolution is 2 pi, yeah, so looks like we're going to have 12 times 2 pi divided by 6. Now, which of those looks like the correct answer? For question 8, it is in fact B. So it's as simple as that. As long as you know that 1 revolution is 2 pi, then you can work it out. So it's not actually 12 revolutions it's 12 revolutions in 6 seconds, so it would be 2 revolutions per second, which is the same as 12 over 2. Okay, so sorry about the confusion earlier. Now we want to go to question 9. And this is about a capacitor. So the capacitors are part of the electric field theory. Now this one is a little bit of algebra you need to know. So a capacitor is discharging through a resistor. Okay. Now you should be familiar with the capacitor circuits. If not, make sure you revise this before your real exam. The time constant, is 5 seconds. Now time constant is equal to a combination of the capacitance times the resistance. So that's what the time constant means. What time is taken, this is what they want you to work out. What time is taken, obviously in seconds, for the charge to halve. So the equation you need to be using is Q equals Q0 e to the minus t, so we're after t, over CR. Now we know CR is 5. We know Q to Q0 is 2. So Q over Q0, you can do it this way, is equal to e to the minus t over 5. Okay, you then have to take logs, but when you take logs, you'll have ln of 1 over 2, that's half, because the charge is now half of the value it started from, because we want to know how long it takes to halve. So the ln of 2 is going to be equal to minus t over 5. Now, you have a minus there, and with logs, if you have a minus there, you can actually get rid of the minus by changing the fraction. So you could rewrite this as ln of 2 equals t over 5. Okay, so all we did here was we made a negative. So a negative of this side and a negative this side. So minus ln of half is equal to ln of 2. Okay, you need to make sure you are aware of these shortcuts. So we want to work out t. So that follows that t is equal to 5 ln 2. Hopefully that is one of the answers. And the answer should be then D according to the mark scheme. And in fact, it is D. Okay? So you need to make sure the capacitor equation for charge, voltage, current, you need to have this equation understood in its different formats for charging and discharging, and you need to know how to use natural logarithms. Okay? Now, question 10 is a car travelling on a humpback bridge. Okay? It is part of a circle of radius r with a mass m and a velocity v. So again, it's to do with circular motion. So again, you need to know that whatever force is towards the centre of the circle, which is in the direction of the weight of the car, you're also going to have a reaction from the bridge. And I've drawn it with the reaction being smaller than the weight because that's what enables it to go in a circular motion. The car is at the top of the bridge, is when we're analysing it. Which of the following expressions gives the force from the bridge on the moving car? The force from the bridge on the moving car is in fact R. Now we know that to resolve this force diagram, you know that mg minus R, so the reaction is actually acting away from the centre of the circle. That's what produces the centripetal force. So this is a true understanding of what's happening in the circular motion. This is Newton's second law. So you want to see which of the answers allows us to give the force from the bridge, which is R. So we just need to rearrange the equations. R and mv squared over R can swap sides. If you're good at algebra, you should be able to see that R is equal to mg minus mv squared over R, and that should be one of the answers, and in fact it is answer C. So that ends the multiple choice section of this exam paper. I hope that makes sense to you. I'll do some other videos on the longer questions. Bye for now.